Alternating current, lecture number 2. AC circuit containing resistance only. Here, this is AC source. Voltage is given by E equal to E0 sine omega t, and this is resistance. So, voltage equation is either V equal to V0 sine omega t or E equal to E0 sine omega t. Here, omega equal to 2 pi f. Current equation I equal to I0 sine omega t. Current and voltage are in same phase. Here, graph is shown. This is E and this is I. Here, phasor diagram is also shown in terms of magnitude. I0 is up to here and E0 is up to here. This angle is omega t. Now, AC circuit containing inductance only. So here, this is inductance. This is AC source, E equal to E0 sine omega t. So voltage equation is E equal to E0 sine omega t, and current equation is I equal to I0 sine omega t minus pi by 2. Current lags voltage by pi by 2. Here current is like this, and then here voltage is like this, and current is starting from here. So current starts from pi by 2, whereas voltage starts from 0. So we can say that they lag by pi by 2. The derivation why current lags voltage by pi by 2 is not in your syllabus, so I'm not going to explain. I will explain it in other videos. So here this is inductor, as I told you earlier. Now inductive reactance. It is the value of resistance offered by an inductance. So it is written as XL, which is also written as omega L, and omega equal to 2 pi F. So it will be XL equal to 2 pi F. Unit of XL is ohm because it is resistance. Now, let's do some numericals. A coil has inductance of 1 Henry. At what frequency will it have a reactance of 3142 ohm? We know that reactance is given by 2 pi FL. We are given reactance as 3142 equal to 2 pi. Pi is 3.142 into frequency is to be found into inductance is given as 1. So from here, F will be equal to 3142 divided by 2 into 3.142. So this will become 1000 times. So it will give 500 hertz. An ideal inductor of 5 by pi Henry inductance is connected to a 200 volt 50 hertz supply. Calculate the RMS and the peak value of current in the inductor. What is the phase difference between current through the inductor and the applied voltage? How will it change if a small resistance is connected in series with this inductor in the circuit? Let's see the solution. As I told you, that in case of inductor, current lags voltage by pi by 2. So here, what is the phase difference between current through the inductor and the applied voltage will be pi by 2. Answer to this will be pi by 2. So because voltage equation is V equal to V0 sine omega t, and current equation is I equal to I0 sine omega t minus pi by 2. Now, question has certain information. Let's write it and then we'll try to solve. L is given as 5 upon pi Henry, and Vrms or ERMS is given as 200 volt. Frequency is given as 50 hertz. Now we can find inductive reactance XL equal to 2 pi FL. We put the values 2 into pi into F, frequency 50, and inductive reactance is, sorry, inductance is 5 upon pi, so 5 upon pi. So pi will cancel out, and this will become 100, 500 ohm. So we have got the value of inductive reactance. Now we have to find out IRMS. So IRMS will be ERMS divided by XL. So ERMS or VRMS is 200 divided by XL is 500. So this will give 0.4 ampere. Now peak value I0 will be equal to IRMS multiplied by √2. So it will be 0.4 times 1.414, which will be equal to 0.5656 ampere. Now, last part, how will it change if a small resistance is connected in series with this inductor in the circuit? So the current through an inductor lags behind the applied voltage by pi by 2, as I told you earlier. The phase difference will decrease if a small resistance is connected in series with the inductor in the circuit. So when resistance is connected, in that case, the phase difference pi by 2 will decrease. Now, question number 3. What is inductive reactance if current through a coil is 800 milliampere and the voltage across it is 40 volt? So here IRMS is given as 800 milliampere, that is 800 times 10 to the power minus 3 ampere, and the voltage VRMS is given as 40 volt. We have to find out XL. So VRMS divided by IRMS is equal to XL. We put the values. XL equal to VRMS is 40 divided by 800 times 10 power minus 3, which will become XL equals 40 into 1000 divided by 800. So it will be 50 ohm. Now let's go to next question. Find the maximum value of current when an inductor of 1 Henry is connected to an AC source of 200 volt 50 hertz supply. So we are given VRMS equal to 200 volt. Frequency is given as 50 hertz and L equal to 1 Henry. We have to find out the maximum value of the current. So maximum value of voltage will be VRMS times √2, that is 200 volt, and let's find out XL, inductive reactance, 2 pi FL. We put the values 2 pi, frequency 50, L is 1. So this is 100 pi ohm. Now we have to find out maximum current, that is I naught, and that will be equal to V naught divided by XL. We put the values. V naught is 200 root 2 divided by 100 pi ampere. It can be simplified, but it's okay. Now, let's see next question. Alternating EMF of E equal to 220 sine 100 pi t is applied to a circuit containing an inductor of 1 by pi Henry. Write an equation for instantaneous current through the circuit. What will be the reading of the AC ammeter if connected in the circuit? So here voltage equation is E equal to E0 sine omega t. So from here we can write E equal to 220 sine 100 pi t. So if we compare this time, E0 is 220 volt and omega equal to 100 pi and omega equal to 2 pi f. So 100 pi, pi will cancel out, from where we will get f equal to 50 hertz. Now we have to find out current. Maximum current I0 will be E0 divided by XL. We put the values. 220 divided by XL is 50. XL equal to omega L or 2 pi FL omega L. So 220 divided by omega is 100 pi and L is given as 1 upon pi. So 220 divided by 100 equal to 2.2 ampere. I think you have understood. Here we can do it earlier also, like we can evaluate XL here 2 pi FL or omega L, and then omega is 100 pi L. So that will give 100 ohm, and then we can evaluate E0 equal to, sorry, I0 equal to E0 divided by XL. We can put the value. Now, here, write an equation for instantaneous current through the circuit. As we know that current lags voltage by pi by 2. So current equation will be I equal to I0 sine omega t minus pi by 2. Here we can put the values. So I0 we have got as 2.2 sine omega t is already given 100 pi t. So 100 pi t minus pi by 2. Now, next part is what will be the reading of an AC ammeter? AC ammeter reads IRMS value. So IRMS we can find, and that would be I0 divided by root 2, and I0 we have got as 2.2 ampere. So we put this value here, 2.2 divided by root 2. So if we put the value of root 2 1.414 and then we divide, we will get 1.556 ampere. We shall answer. Thank you for watching.